Hello, everyone. Good evening. Welcome back. So we are back here with next session on Diophantine Equations, Algebra. So I planned a third session because I felt that a lot of scope is there again to deal with different kind of questions. So we have already gone through two sessions. So I hope everybody is clear with the agenda, right? Questions involving either linear equations or quadratic or even higher degree polynomial based problems, and the variables or quantities involved, they exhibit the integer condition, and that condition is either explicitly stated in the problem or not really explicitly mentioned, but we have to figure it out, and then based on that the problems are solved, right? Okay, so let's see what more things we have here. Okay, so something purely on variable based analysis, variable based problem. The sum of reciprocals of two positive integers a and b is 1 over 5. If a is more than b, then we are asked to find the ratio of a plus b is to a minus b. All right. So let's write the equation just then let's see what we can do with that. So the sum of reciprocals. So reciprocal 1 over something. So of two positive integers, condition is mentioned clearly, a and b. So 1 over a plus 1 over b, sum of reciprocals is 1 over 5. That's the equation. We have to find a plus b is to a minus b. So the integer constraint, and we have such kind of equation again. So you know, just going very completely outside. So you know, so Diophantine equations need not even be polynomials. They can. So this is not a polynomial equation at all, right? Something non-polynomial equation. But let's see what we can do. Obviously, we'll simplify this. So let's take the LCM. A into b, a plus b over a into b is 1 over 5, and then cross multiply. So 5 times of a plus b equals a into b. So a into b equals 5 times of a plus b, right? And we're looking for positive integer solutions to this equation. A into b minus 5a minus 5b is 0. So the agenda is, or the target is, to kind of express this equation in a factorized form, right? So that we can apply some integer constraint logic, right? So the way this is written, obviously we'll have to keep something like a something and b something to get a into b, and then some constants added to that. Since we have minus 5a, so I need to write minus 5 here to get minus 5a, and likewise minus 5b, so I'll need to write minus 5 over here. But from this I do get these three terms, but I also get 5 into 5 25, which was not there to begin with. So therefore, to balance the equation, I will need to write 25 on the right hand side. Now this is exactly same as this equation, right? Now, since we are dealing with integers, so a minus 5, b minus 5 are also positive integers. In fact, they're integers, sorry. And 25 needs to be expressed as the product of two factors, right? Over here to match up with this. And since a is more than b, so I need to write a higher value over here. The first possibility could be 25 into 1. If I do any other possibility, it will not suffice this condition, because 25 is only 5 into 5. So either you can write it as 25 into 5, 1, or as 5 into 5. But 5 into 5 will make a and b equal. So this is the only possibility. So you have got your solution, right? So with all the constraints at the end, you're getting the unique values. A minus 5 should be 5, a minus 5 should be 25, which means a is 30, and b minus 5 is 1, so b is 5 plus 1, 6. Then a plus b over a minus b we can easily figure out. A plus b is 30 plus 6, 36. A minus b is 30 minus 6, 24. 12 into 3, 12 into 2. So what is this? This is 3 by 2. This is 3 by 2, right? So a non polynomial equation. What was the agenda? express it in a factorized form, simplified, and then the number logic kicks in. How to break 25 as the product of two factors? The only way it works is 25 times 1. Right? Okay, next one. Again, something purely on variables based. Two integers a and b satisfy this relation. A square plus b equals 92 and a plus b square is 112. Then we are asked to find the value of a square plus b square. Now, if you feel that, okay, these are two equations, two variables, I can do substitution and create a single equation in one variable, you see the complexity that will come across. You see, this cannot be solved by the typical algebraic method, because I'm just showing you why we cannot solve this question by the typical algebra method. You see, if you want to substitute, okay, b is 92 minus a square. Okay, let me put this in the other equation. What does it give me? A plus b being 92 minus a square, the whole square. Do you see what complexity we're getting into? Is 112, it's a fourth degree polynomial. Up to the cubic, we can think of doing hidden trial, but fourth degree, really complex, doing hidden trial. So therefore, this is not something that we can solve. We are getting a polynomial, no doubt, but that polynomial is not something that we can manage to solve, right? So either you can do number fitting here, or you can do number fitting here itself, right? Either which way you do number fitting, you cannot solve this algebraically, right? Okay, so let's think either which way, either here or with this system of equations. What can we do over here? What can I assign as the value of a, let's say? Hmm? Okay, let me try to see what maximum value I can put for a. 92 minus a square, the whole square, should not be crossing 112. A certain perfect square should not be crossing 112, right? So the number inside the perfect square should be less than of equal to of 10, right? Can I say 92 minus a square is less than equal to of 10, right? Oth- Other, right? So that this perfect square is at the most 100, we cannot cross that. So a square is coming to be greater than or equal to of 92 minus 10, 82. Hmm? All right. So a square is greater than equal to 82. 81 is 9 square, right? What if I put a equals 9? Will that work? On the very boundary, if I put a as 9, just on the boundary. Okay, this will cross the limit actually. 92 minus, if I'm putting a as 9, 92 minus 81, the whole square, right? If I'm putting a as 9, 92 minus a square is 92 minus 81. This is 11 square, 121. Now I know I have crossed the limit of 112, but 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 just think of this. I know this has crossed the limit of 112, but who says that a needs to be positive? Who says that this term cannot be negative? So there's a very beautiful solution here. A hidden trial approach is definitely required, and the fact that putting a equal to 9 is not possible, because this is already 121 plus 9 would be 130. But instead of putting it as 9, what if I had put a as negative 9? Even for negative 9, this would be 92 minus 81, the whole square, 121. And by putting a as negative 9, minus 9 plus 121 is exactly 112. So that's the solution that was required to be identified, right? So that's the only integer solution that can work over here. By chance, the first hidden trial that I did give me the solution. You can keep on trying with any other values, they will not give you the solution, right? So a equal to negative 9 works, and correspondingly what is b? A square plus b is 92. So 81 plus 11 is 92. So a is negative 9 and b is 11. So this is the values which satisfy both these equations. Hence we can mark the answer that a square plus b square is 81 plus 121 or 202. That's the answer. Right. So the such kind of purely variable based, integer based constraint questions can also be there, have been asked. We have seen this last time also, if you recall, which involved uh, radical values, means cube root, square root. We have done that also. Okay, next one. Now some interesting word problem we have for the next one. uh, Now, this is not a typical question of sequences. It's beyond that. Uh, the 11th term of an arithmetic progression in which all terms are positive integers is the largest two-digit prime number. All of us know what is the largest two-digit prime number. So the question is telling you a value a bit indirectly, 97. So basically the 11th term of a AP in which all terms are positive integers. Here kicks in the integer constraint. So if I define the AP as that in the typical manner, that the first term is A and the common difference is D. So the terms are A plus D, A plus 2D, and so on, right? So the 11th term, right, will be A plus 10D, and that is given to us directly as 97 is the first information, right? And its 25th term is also a prime number greater than 200. Okay, which of the following is one of the terms of the progression? In order to find which of the following is one of the terms of the progression, I have to find both a and d. Now I do have two equations over here, but the second equation does not have a a number on the right hand side, because the second equation is that the 25th term, which would be a plus 24d, 25th term, is a prime number p which is more than of 200. That's the second information. So actually you have two equations but three variables effectively. So therefore that this positive integer constraint is the now the criteria based on which we should be able to get something for which a and d need to be positive integers. A and d are positive integers. All right, so let's eliminate one variable at least. Let's do one thing. Let's put in a as 97 minus 10d in this equation, right? Because then we have also have this inequality condition. So perhaps something might come across, right? So putting this over here, we can say, so 97 minus 10d plus 24d, right? So I'm writing now for the second equation. So the 25th term becomes 97 minus 10d plus 24d, which is plus 14d. Now this needs to be more than of 200, right? 97 plus 14d is a prime number more than 200. Okay, so I'm getting some constraint on the common difference d over here. 14d is more than of 103, 200 minus 97. 14 into 7 is 98. 14 into 7 is 98. 7 also won't work. But 14 into 8 is 112. That would work. So d, can I say, is at the minimum 8 and beyond. Now we can do our number fitting, given that we have figured out this minimum constraint on the common difference. So what if I start doing my trial and error process? Let me see what happens if I put d is equal to 8. Because as I keep on putting the values of d, so from the first equation, I'll keep on getting the values of a. And then I can see what I'm getting for the 25th term. So if d is 8, putting in the first equation, so a becomes 97 minus 10d, 10 into 8, 80. So the first term becomes 17, which means that the 25th term is a 17 plus 24 into 8, 24 into 8, which will be 192. So this is 192 and 17, 209. 192 and 17 is 209, 209. Uh, so let's do the check of prime. 2 is not a divisor. 3 is obviously not a divisor. 5 is also obviously not. 7, 14, then 69, no. 11, 11, and then 9, 99. Yes, it's divisible by 11. It is 11 into 1 and then 9. So it is 11 into 19. So it's not a prime. So it's not my solution. So fail. Right. So failure is always the path to success. We know that answer is going to come very soon. D equal to 9 is the next possibility. And given that a plus 10d equals 97, a and d being positive, we now know that this is the only possibility left out, because a is now 97 minus 10 times a 90 is 7. If I put d is equal to 10, I'll get a negative value of a, 97 minus 100. So therefore this must give us the correct answer, right? So it was because of this further prime condition on the 25th term, due to which the d equal to 8 case fails. D equal to 9 case gives us a is 7. So this now must be the prime number. We can confirm the 25th term is coming to be a plus 24d. 7 plus 24 into 9. 24 into 9 is 216. 216 plus 7 is 223. 223 indeed is a prime number. Okay, so the question is not what is the value of the 25th term. Question is asking something else. So we have figured out a as 7 and d as 9. Right? We have figured that out. We have figured this out. First term is 7, common difference is 9, which means the sequence is such that the nth term is 7 a plus n minus 1d. So 7 plus n minus 1 times 9, basically implying that the terms are a multiple of 9 plus 7. So the terms should leave the remainder of 7 when divided by 9. So which is that term? Not a, it will leave the remainder of 2. Sum of digits I'm doing. 4 plus 1 5, not the answer. 6 plus 1 7. Yes, 1006 is a number which is a multiple of 9 plus 7. 999 plus 7, right? So a question full of multiple concepts: integer constraint, prime number, making the cases, right, doing the prime check, right, and finally getting the unique answer at d equal to 9. It works. All right, time to look at some previous year questions. Oh, one more question I have brought from my side. Okay, uh, let's see. Now back to pens and pencils. Right, all of us like our childhood, remembering that. Abhay spent exactly 1,000 rupees for buying pens and pencils. Wonderful. 1,000 rupees. Oh my god. Each pen costs 25 rupees and each pencil costs 5 rupees. Okay. Had Abhay bought the number of pencils equal to the pens he bought and pens equal to the pencils he bought, so he's doing the swapping, his total spending would have been less than half of what he originally spent. At most, how many pencils could he have bought originally? Okay, let's jump in. Let's say X pens and Y pencils, right? If he bought X pens and Y pencils originally, then so we only have the 1,000 rupees, the equation on 1,000 rupees. So 25x rupees spent on pens and 5y amount spent on pencils is 1,000. Remember the objective. At most, how many pencils could he have bought originally? So we have to figure out the maximum possible value of y, the number of pencils that he originally bought. 25x plus 5y is 1,000. 5x plus y is 200. Linear equation, we know how to find all the solutions. Now, before we write the solutions, let us write the further constraint. So if he does the swapping, pens equal pens, pencils equals pens, pens equals pencils. So what he would have spent? So this if then constraint, that is saying that If he had bought Y pens and X pencils, if he had bought Y pens and X pencils, which means that 25 into Y, right, plus 5 into X. So this amount, if he had spent, would have been less than half of what he originally spent. So this is less than half of the original amount, which is 25x plus 5y. So we'll get some inequality from here also on x and y. Let's work that out. 5y plus x, I'm cancelling 5 on both the sides. Twice of this is less than of 5x plus y, right? 2 comes here, 5 I've cancelled on both the sides. 5y plus x, 5x plus y. I'm getting 10y plus 2x is less than of 5x plus y. Okay, so 5 minus 2, which is 3x, 5x minus 2x, 3x is more than of from here, and 10y minus y, 9y, which means x is more than 9, which is means 3x is more than 9y, so x is more than thrice of y. X is more than thrice of y. You see, whenever there is this question of maximization, this question is of maximization. At most, how many he could have bought originally? Pencils. So always there is going to be a constraint to oppose that maximization. You are trying to maximize the number of pencils, but the condition, the mathematical condition is that pens should be more than thrice of pencils. So in that, what is the best case possible, right? So both these constraints have to be satisfied, this equation and this limit x is more than thrice of y. Okay, so now we can start to write the solutions of x and y in this equation and figure out what is the best that we can do. Mathematically speaking, I always start from, if I see this constant to be a multiple of one of the coefficients, I always put the other variable as 0 and start my solutions. 40 comma 0, right? 40 into 5, 200. I know this is not a solution, but from here I'll get the further solutions. Now x will keep on decreasing by 1, the coefficient of y, and y will keep on increasing by 5, the coefficient of x. So 40 can become 39, 0 can become 5. 39 is still more than thrice of 5, 15. So I have this is valid, and I hope that I can. So I'm increasing y. I want to find the maximum limit I can reach for y, isn't it? So can I go for the next possibility? Will this constraint still be satisfied? That is my point, right? So 38 and then 10. 38 is more than thrice of 10, 30. 30 is more than 30. This is still valid. But this is quite neck to neck. 30 and 30 are quite close. You can see we are increasing y in multiples of 5. I really doubt that the next solution would satisfy this constraint. You can see it will not. This will become 37. This will become 15. 37 is not more than of 15 into 3, 45. Right? So this is the best case, and our answer is simply 10. Right? 10 is the best possibility that he can do for buying pencils. Right? So linear equation, integer constraint, and an inequality to be satisfied. All right. Now let's see. A vintage question, CAT 2005, but very brilliantly designed problem. Let's see. Some aspect of geometry is also involved in here, because we're talking of a rectangular floor. A rectangular floor is fully covered with square tiles of identical size. A rectangular floor is fully covered with square tiles of identical size. Okay, so I can imagine just the way typically our rooms are built with tiles. The tiles on the edges are white and the tiles in the interior are red. Okay, so I get a sense of this. The boundary is having a different color, the inside are differently colored. The number of white tiles is the same as the number of red tiles. Okay, now this is the mathematical condition. It will give us my equation, but equation involving what variables? That's the thing to think about. A possible value of the number of tiles along one edge of the floor is what? So last statement tells me you have to define the number of tiles along each of the two edges, which means the length and the breadth, as the variable. So if you have m tiles, let's say, along one edge and n tiles along the other, So in total you have a grid of m by n, so a total of m into n number of tiles, and you are talking about tiles in the interior and on the boundary. Okay, uh, let's let's understand it through a bit of small diagram over here. Let's say this is my rectangular floor. I need to leave out the boundary. Okay, let me draw the boundary here. Okay, so I have left one tile space all around. Okay, so originally if it was a m by n grid, which means m tiles along this dimension, if they were, so I want to define the number of tiles along the inside, the interior. So if it was m tiles across the entire boundary, then I have left one tile from here. I have left one tile from here. So in total, two tiles have been left out. So can I say this interior is a grid of m minus 2 on one edge, and likewise if this was n tiles in total across the other edge. So once again I have left one tile from here and one tile from here. So therefore this, the inside, the other dimension is n minus 2. So the inside number of tiles are m minus 2 cross n minus 2 grid, and it is given that the white tiles equal the red tiles, effectively telling me that the interior tiles, twice of that, can I say, is the total number of tiles, because the white tiles equal the red tiles, right? And white plus red make up for the total number of tiles. So can I say twice of the number of red tiles equal the total number of tiles? From here I can create some equation. Total number of tiles are m into n, is twice of the number of red tiles, which is a grid of m minus 2 cross n minus 2. So is twice of m minus 2 n minus 2, right? M into n. So this is the equation that we have with m and n. We have to figure out the possibility of one of the values of m or n. Obviously m and n are integers. These are number of tiles. Let's see what we can find from here. Mn is twice of mn minus 2m minus 2n plus 4. Mn is 2mn minus 4m minus 4n plus 8. Now this is looking very similar to what we did in the first question, isn't it? Where we factorized it out. So something similar we had to do. So let's do that. Mn, this comes over here, minus 4m minus 4n plus 8 is 0. So again, we can do that kind of factorization here. M minus something, m minus n minus something, this is also minus. So m minus 4, n minus 4 is what we need to get mn minus 4m minus 4n. But the constant term we are getting is 16 on the left hand side. But the constant term was only 8. So to balance on both the sides, I must write 8 on the right hand side. See, mn minus m minus 4m minus 4n plus 16 equals 8 by adding 8 on both the sides. All right, so finally we can say that m minus 4 and n minus 4 are factors of 8. They can be 1 and 8 also, or 2 and 4 also, and these are the only two solutions, nothing else, right? There are only two ways to express 8 as the product of two numbers, either 1 and 8, 1 into 8 or 2 into 4. If m minus 4 is 1, then m is 5. If n minus 4 is 8, then n is 12. 12 is the answer, right? I see there. The other possibility could have been 4 plus 2 6, 4 plus 4 8, right? So either it's a 5 by 12 grid or it's a 6 by 8 grid which satisfies the given constraint. A very brilliant question. No numbers anywhere in the question, but once you frame the problem carefully uh, and geometrically analyze the situation and create the equation for that, you get these numbers, right? I think one of the best questions I've seen from CAT. All right. Uh, let's see. A ZAT 2018 question. Next one. Quadratic roots, common roots. Okay. Let's see. Two different quadratic equations have a common root. Wonderful. Let the three unique roots be ABC. So there will be common root. So in total, there will be only three unique roots. Let's say A is the common root. So let's say the first quadratic equation has A and B as the roots. Then the other one will have A and C. Right? Uh, there is no specific thing mentioned that which one is the common root among A, B, C. So I can call any one amongst these three as the common root. Then he says that A plus B plus C is 41 and the product of the roots of one of the equations is 35. Right, you have already looked at this positive integer constraint clearly mentioned, right? So the roots are positive integers. Wonderful. So we just have to do some number fitting over here, that's all, with the given constraints. A plus B plus C is 41. So our first quadratic equation has the roots, let's say A and B. The second quadratic equation, let's say, has the roots A and C, right? It is given that the first, I'm calling this as quadratic equation, the first one, the product of the roots is 35. 35 can be expressed only in two ways as the product of two positive integers, right? But remember, which one is the common root also is a constraint. So although 35 can be expressed in only two ways, but which one is the common root further will have two possibilities. So I think I'll have two into two, four cases, right? If I take common root as 1 into 35 is 35 and 1 is the common root. Then 1 plus 35, 36, 36 plus C is 41, C is 5. 36 plus 5 is 41. So the other quadratic equation has the roots 1 and 5. Remember, we are searching for we are analyzing all the possible ways to satisfy the conditions, and then we have to look from the options that which of the following is definitely correct about the possibilities. So we need to list down all the possible ways that we can define the roots. Now remember, we can swap this and this is a different possibility because the common root being 1 and 35 are two different scenarios. But C would still be 5 because A plus B 36 plus 5 41. But the common root is 35 now. 35 and 5, sorry, 35 and 5. The other case of 5 and 7. So 5 and 7, 12, 5 plus 7, 12, 12 plus 29 is 41. So here 5 and 29. Or other way around, 7 and 5. Common root is 7 and the other root is 29. Perfect. Now look at the options. Which of the following is definitely correct? The common root is 29. That is definitely not true. 29 could be one of the roots of the other equation, but 29 is never the common root. Smallest root is 1. Smallest root could be 1 or it could be 5 from these last two cases, right? In the first two cases, common root is 1. So this is a possibility, not a guarantee, not definitely correct. C, one of the roots is 5. 5, 5, 5, 5. Yes, that's my answer. Right. So, just had to carefully plug in the numbers, just satisfy all the constraints, right? And we got four possible scenarios, and we had to properly analyze all the cases, right? Without properly analyzing all the ways that the conditions can be satisfied, right, you cannot answer the question, right? For example, let's say by mistake you, let's say, had only analyzed the first two cases, then you could have said, okay, smallest root is 1, right? 5 and 7 case also had to be analyzed. All right, next one. A confused bank teller transposed the rupees and paisa when he cashed a check for Shailaja. giving her rupees instead of paisa and paisa instead of rupees. Well, let's see whether Shalja is in the is in the like, is she getting some benefit out of this or loss? If it was 20 rupees 50 paisa, and if he had transposed, Shalja is lucky. Okay, she got more, 50 rupees 20 paisa. Or so, after buying a toffee for 50 paisa, Shelja noticed that she was left with exactly three times as much as the amount on the check. Oh, she's in the good books. She has got more than what she should have got. Right? She has got more than thrice of the amount on the check. More by 50 paisa. CAT 2007 question. Rupees and paisa, two variables are involved. Which of the following is a valid statement about the check amount? And all the options are about the range of the rupee amount, in the range of 1 rupee only, 13 to 14, 7 to 8. So basically the rupee is how much, that is we have to find. Let's see. So to analyze, we need to take both rupee as well as paisa as the variable for sure, right? So let's say that the check read x rupees y paisa. Let's say the check stated that Shelja should get x rupees and y paisa. This was the intended amount what check read. But what she actually got, what she actually got is the transposed value of y rupees and x paisa. So you see, our equation is in terms of the monetary value. Now monetary value is total of rupees and paisa, and we have taken the rupees and paisa as two distinct variables. So think about the equation that we will write. It has to be total value. Let's just, I'm just saying for clarity, let's say this was 4 rupees 10 paisa. So what is the amount? 4.1 rupees. Now in terms of x and y, what would I rate? X is 4, y is 10. Either I say x plus, so if I want to write in terms of rupees, so x, and 1 paisa is 1 by 100th of a rupee. So either I say x plus y by 100 rupees, so 4 plus 10 by 100, 4.1 rupees, or I say 1 rupee is 100 paisa, so x rupees is 100x paisa. So 100x plus y paisa. I don't like writing fractions, so let me write in terms of paisa. So can I say x rupees and y paisa is a total paisa of 100x plus y? That's the total amount actually in paisa terms, 100x plus y. This is what she should have got, but what she actually got, and you know, in the end was 100y plus x. This 100y plus x, even after decreasing 50 paisa from that, she still actually is left with thrice of the check amount, right? So the equation becomes 100y plus x is the paisa amount, 50 paisa toffee, so minus 50. This much is still thrice of the check amount, which is 100x plus y. So I have a linear equation in two variables. The only thing is, little bit coefficients are a bit large ones, right? So we have done this many times, how to find the linear equation, integer solutions. But I have kept this question to understand and analyze how to search for the solutions when the coefficients involved are very large. You see, what we are getting after simplifying is 300x and x, 299x, and 3y and 100y is equal to, so 299x and plus, let me bring 50 on this side, so 299x plus 50, and that equals 97y. Right, 100y minus 3y, 97y equals 299x, and 50 goes over there plus 50. Okay, so you see, what you should do is, with these large coefficients, it's a bit difficult to directly do hit and trial. Multiple of 97, multiple of 299, you know, difficult to just do, start putting x equal to 0 1 2 and then keep on dividing by 97 2. So to make things simple with such large coefficients, what you should do is, You see, keep 97y on the left hand side, okay, and the right hand side is an expression which also it needs to be a multiple of 97. So from these coefficients, separate away the largest multiple of 97, which means 97y is 299 is what nearest to what multiple of 97? Thrice. 97 into 3 would be 291. So let me separate off 291x. Then what I'm left with is 8x plus, right? 8x plus 50 is left. So this 8x plus 50 is easy to work with, in the sense that this 8x plus 50 needs to be a multiple of this 97, right? So let me start putting the values of y as 1, 2, 3, and let me see when do I get an integer value of x. So my 8x plus 50, first of all, needs to be even. First of all, 8x plus 50 is an even number, so I need not even consider or multiple of 97. I should start with 97 into 2, which is 194, right? That is the first possibility. Now with that, I'm getting 8x to be 194 minus 50, 144. Oh, bingo. The first solution itself is, I mean, the first hidden internal itself has given us the valid value. I'm getting x as 18. Option D is rupees 18 and some paisa. Right? You can also find the paisa by putting back x as 18 in the original equation. All right. So again, I hope this was fun, and we are completely clear with how to deal with these kind of problems. All right. So thank you so much. I'll see you very soon in the next session. Thank you so much, and stay in touch and stay connected. And anything, any suggestions, any comments, any questions, do let me know on the chat box. Right? Thank you so much. See you in the next time.